Hello class, welcome to our next set of notes, which is over two-dimensional figures in chapter 1.6. Remember to put the date at the top right hand corner of your notes. The first definition we come across is polygon, which we will define as a closed figure formed by sides. Again, that's a closed figure formed by sides. Now, when we look at our problem, we have a diagram of what a polygon looks like. Now, just like angles, polygons have vertices, which are the points where the angle are formed. In this case, it is each endpoint of the sides. And then we also have sides, which are the lines that connect each vertices together. Now, when we have a polygon, they have to be closed, like our definition said, which means that if M and K were to not touch J, and there was an opening, it would not be considered a polygon. So a makeshift example would be if we had a figure that looked like this. So we have 1, 2, 3, 4 sides, but they all don't connect to each other, so that would be an open figure. So that's kind of the definition of a closed figure is. Now the way that we describe a polygon, all we need to do is list the 4 vertices in correct order. In this polygon, we can simply call it polygon MKJL. So since this polygon has 4 sides, it has 4 sides and 4 vertices, we need to make sure we list those in order. And we're going to go MKJL. Now the order isn't important, so if you want to go MLJK, that is okay. However, you need to make sure that the way you go about the polygon is the correct order. Now, there are 2 forms of polygons we will encounter. The first one we're going to encounter is convex, and the second is concave. Now, in order to be convex, that means all our angles have to be on the exterior. So the easiest way to look at a problem like this is if we were to make lines for each side. If none of those lines pass the inside of our polygon, which we are going to label in blue, we can say it is convex. So the lines that go through the sides cannot interfere with the inside or the interior of the polygon. Now if we were to look at the concave polygon, when we create ON, PQ, and we also create MR, those all go within our polygon, so those lines intersect with the interior. Now the other ones, such as OP and LT, do not intersect with the interior. However, the fact that MR and PQ and ON, those lines pass through the interior, we will call that concave. So that's the big difference between the two. We can draw lines, and if it passes through the interior, it's concave. If it does not pass through the interior, it is convex. Now we are going to look at the different kinds of polygons we have by sides. So if we have a polygon that has 3 sides, we call that a triangle, which most of you have probably heard. So 3-sided polygon is a triangle. A 4-sided polygon is a quadrilateral. 5-sided is pentagon. 6-sided is hexagon. 7 is heptagon. 8 is an octagon, which if you think of a stop sign, that's an octagon. 9 sides is a nonagon. 10 is a decagon. 12 is a dodecagon, and depending on how many sides, more than 12, you'll call it n, or what you can say is 13gon, 14, etc. Now, the next definition we come across is an equilateral polygon. The definition for an equilateral polygon means that all sides are congruent. So, on a equilateral polygon, we can say that all the side lengths are equal. So if one side length is 5, all the other sides are also 5. Now an equiangular polygon, that means that all angles are congruent. So if we look at an equiangular polygon, all the angles on the inside are going to have the same measure. So if one angle is 45, then the rest of them are also 45. Finally, we also have regular polygons, which can be defined as a convex polygon that is equilateral and equiangular. So it has to fit three things. It needs to be convex, it needs to be equilateral, or like we said, all the sides are equal to each other or congruent, and also equiangular, which the angle measures are equal or congruent. Again, that means that the regular polygon has to be convex, equilateral, and equiangular. In example 1, it tells us to name each polygon by its number of sides, then classify it as convex or concave, then also classify whether it is regular or irregular. So first off, we're going to name each polygon by its number of sides. So in this case, we have 1, 2, 3 sides. So that means in part A, we have a triangle. Okay, so we have a triangle to start with. And then it tells us to classify it as convex or concave. So remember, the test for convex or concave, we are going to extend the sides and see, does it pass through the interior of this polygon? Which in this case, none of those lines pass through the interior. So we can automatically say that it is also convex. And then finally, it tells us, is it regular or irregular? So when we look at this problem, we have to ask ourselves, to be regular, it needs to be convex, equilateral, and equiangular. So we've already checked off that it is convex. So we're good there. Now we just need to check, is it equilateral and equiangular? If it is not all of those three, it is automatically irregular. So first we check to see, is it equilateral? Which, when we look at these little side tick marks, what those mean, since it only has one apiece, that is saying that each of those sides have the same length measurement. So in this case, we can say yes, it is equilateral because all three of those sides are congruent to each other. Now the last part is it equiangular? So we look at these three arcs that are made here in the triangle, and we see that those all have just one arc apiece. Now remember, when we talked about those in angles, if they're the same amount of arcs, they are congruent to each other. So we say that this problem, they are equilateral, equiangular, and convex. So we can automatically say that this problem, or this polygon, is regular. Now in part B, it asks us to identify the polygon by its number of sides. So in this problem, it has 1, 2, 3, 4, 5, 6, 7, 8 sides. So that means this problem is automatically an octagon. So since it has 8 sides, this kind of polygon is an octagon. Now it says classify it as convex or concave. Now this problem is exactly like what we had up top. When we extend the lines through, we only have to find one example to show that it is concave. We don't have to find multiple examples. So in this problem, we have already found 2 lines that pass through the interior, so that makes it automatically concave. So we can say that this polygon is concave. And now our final test for being regular or irregular. Remember, it has to satisfy 3 parts. It has to be convex, equilateral, and equiangular, which it doesn't even satisfy the convex. So that automatically means that this problem is an irregular polygon. Now let's take a little closer look. When we talked about the segment lengths, we said if they have one tick mark along the segment lengths, those are equal to each other. On the other segments, they have 2. So what this means is the side length that has 1 is different than the one that has 2. But all those that have 2 tick marks are all congruent to each other. So this is how we'll be denoting whether side lengths are congruent or not. Now please go to part 2 of chapter 1.6 notes over 2-dimensional figures.